Okay, welcome back to Physical Chemistry. We're beginning Chapter 12 now. We're in Section 1. Chapter 12, we're going to be talking about multi-component phase equilibrium. And first, let's talk about colligative properties. Colligative means bound together. So we're talking about properties of what happens when you mix substances together. The first colligative property is vapor pressure lowering. The second colligative property is freezing point depression. The third colligative property is boiling point elevation. And the fourth colligative property is osmotic pressure. So, let's see here. Here's a couple of reactions. I don't know why this is actually here. So we have chlorine plus H2O. We're going to get HCl plus HClO. Okay. And likewise, iodine plus H2O. We're going to get hydrogen iodine and hydrogen iodate. I don't remember why that was there. It must have been from a previous problem. Okay, so here is a example of a phase diagram. So here's pressure versus temperature. So this line here, the solid lines, this is what happens with pure water. All right, so let's see here. High pressure, low temperature. This would be different phases here. I should have labeled it actually. So like higher temperature, this would be gas under here. So this would be liquid and then solid. So what happens if we add some sugar, sucrose, we get the dashed line depending on the exact amount we do. So we here the temperature, T sub F is the freezing point, star means unmixed, the pure water, and then just T sub F, that means with the sucrose. See, notice how the freezing point went to lower temperature. So that's our freezing point depression. Likewise, here's your T subscript B, so your boiling point, star is unmixed. So this is your boiling point of pure water. And then this would be just your boiling point with the sucrose added. So as you can see, the boiling point changed. So there's a change in pressure, or a change in temperature due to boiling. There's also a change in pressure if you're at the same temperature here. So we say we're going to have lower pressure or an increase in the boiling point. And then you can't see osmotic pressure on this one. So again, the delta P, that's your vapor pressure lowering. And like I said, on that diagram, osmotic pressure can't be shown. But adding something to a solvent, water in this case, makes its chemical potential drop. Now remember, the partial derivative of the chemical potential of A with respect to the mole fraction of A, holding temperature, pressure, and everything else constant, is greater than 1, as long as A is the solvent. Now the chemical potential of A is equal to the chemical potential of A unmixed at whatever temperature and pressure, plus RT times the natural log of the mole fraction of A. Since mole fraction is less than 1, this whole term is negative, so the chemical potential drops. Now remember, X sub A is equal to 1 for a pure solvent. In this case, we're talking about water. And then mole fraction of A less than 1 after you've added some of the solute. That's all for section 1.